Some other little tiny things I want you to notice. When you did x plus y and had the whole thing squared, when you wrote it out, do you see that you got three things? You got x squared plus 2xy plus y squared. So the exponent here of 4, if you had an exponent of 2, you get three things. How many are you going to get with an exponent of 4? You're always going to have one more term than the exponent. So at 5 terms, I look at my Pascal's triangle here. How far do I have to go until I get 5 numbers? Right here, 1, 4, 6, 4, 1. So if I want to do 3b minus 1 to the 4, I know that I'm going to have 1, 4, 6, 4, 1. Spread those out. When we had x and y, what did we start with? We started with x to the 4. But this time we have a 3b. Does it make sense that we're going to start with 3b to the 4? Plus. The next one's going to have 3b cubed and then negative 1 once plus. Then the 3b will be squared and the negative 1 will be squared plus. 3b just once and the negative 1 cubed, then plus, and the last one, the negative 1 4 times. This says expand. This is expanding. And it says simplify. So we now have to do our exponent laws. 3 to the power 4, 81. B to the power 4, b to the 4, plus 4 times, I'll just simplify this one. 3 to the power 3, 27b cubed, and then that's still multiplied by negative 1, plus 6 times, if I square that, 9b squared. If I square this, positive 1, plus negative 1 cubed is still going to be negative. I'm going to multiply those together. I'm going to get 12b times a negative 1. And then negative 1 to the 4 is going to be a positive. So I just tried to do all my exponents first. And now, do I have any other math I could do? Yes, this is still going to be 81b to the 4. Here, 4 times 27 is 108 times a negative 1, negative 108b cubed. 6 times 9, 54, plus 54b squared. 12 times a negative 1 minus 12b plus 1. There's our final answer. The question is, was this quicker than our old technique would just be like, use your arrows, multiply 2 together first, get an answer, then multiply all those together, then gather all your like terms and simplify? Which is less work? You're like, I don't want to do either. Well, this is the algebra part of what we're doing. And as part of the algebra part, usually on a test, they don't ask you to find all of them. They just ask you to find one of them. Right? They might say, can you just find term 2? We call this term 1, we call this term 2, this one the term 3, this one term 4, this one the term 5. Can you just find one of them? Save you some time. And this is where the pattern comes in. Okay? On your formula sheet, you have the following formula. It says, for a plus b to the n, you can find any term number k plus 1. And we're going to talk about why it's k plus 1. Okay? It's going to equal. I'm going to write this first part in blue. Okay? And I'm going to put term 2 in a green box here, then a green box here. Because we're going to use term 2 as our pattern. In Pascal's triangle, 1, 4, 6, 4, 1, would you agree that in term 2 that 4 is 4 choose 1? Right? Same thing, and when we had the 11 as the second one, I said I use that second one to figure out what it's going to be. Okay? Well, where does the 4 choose 1 come from? Well, the 4 is always the same as your exponent. So in the formula, I'll write this part in blue. That's green. There we go. And this is why we have a k plus 1 here. If the second term is 4 choose 1, then if k is 1, 1 plus 1 would be 2. And then I would just have n choose k. What do I have here? Well, whatever the 3b is, that's the first part. In this here, that would be a. I'll go back to black. I'll go back. A. And how do I figure out this exponent? Well, it goes down by 1 each time. And it actually shows up as n minus k. For term 2, is this not 4 minus 1? And then b is just to the exponent of whatever k is. This formula is on your formula sheet. So if you wanted to find term 2, well, term 2, then k would have to be 1, because the only way I'd get on this side term 2 is something plus 1 equals 2. Oh, k has to be 1. I just plug things into my formula. N is my exponent. In our example, the exponent was 4. Choose k, well, I already said k was 1. In our formula, a was 3b, and this will be to the 4 minus 1, and b was negative 1. If I go to my calculator and do each of these separately, 4 choose 1, that's 4. Exponent would be 3. 3 cubed is 27. B cubed. And negative 1 to the 1 is negative 1. And now if I put my numbers together and multiply 4 times 27 times negative 1, I get negative 108. And I still have the b cubed. There's term 2. Did it match up with what we found when we did the whole expansion? It did. So we have this formula. It's on your formula sheet. It is listed on page 741 in a little bit different way. So I'm going to go take you to page 741 right now. They have it listed for term k. Right underneath here, this is how it's on your formula sheet. It's actually easier if it's listed for term k plus 1. So the textbook's formula, instead of having k's, they have k minus 1 here, which makes it k minus 1 k. It's more awkward. So it's easier if you write it for term k plus 1 rather than term k. And the textbook has it for x and y to the n. Your formula sheet has it for a plus b to the n. Both are exactly the same. Okay, questions for example 1. You can circle number 3 and 4. we'll do another one completely with an expansion.